Good morning, grade 11. Today, inshallah, we're gonna start in section 3 of chapter 6. We keep talking about the chemical bonding, and as we know, there are two major types of chemical bonds, covalent bond and ionic bond. We know the main difference between them that in covalent bond, electrons are shared between atoms, while in ionic bonds, there is an atom that will lose electron and turn to be cation or positive ion, and there is another atom that will gain this electron and will turn to an ion or negative ion, then a kind of electric attraction between them will occur or will attract them together to make the ionic bond. So today, inshallah, we're gonna talk especially about how the ionic bond is formed and what are the characteristics of ionic bond and so on. So first of all, we said that most of rocks are the most minerals that they already found in the Earth's crust. They are already made of attraction between negative ions and positive ions, which means they are already ionic compounds or they already bonded by ionic bonds. So which means that they already more abundant in the Earth's crust compared to the covalent compounds. That's why we need to study them well. So here we said that, for example, the table salt in a cell that could found in the natural rock in the or the natural large amount nature rock called halite. So it's made of sodium and chlorine, in which sodium ion of or positive sodium ion combine with negative chlorine ion, forming the table salt or the halite, as we said. In ionic compound, okay, it happens as we said when the positive and negative ions they are attracted to each other. Okay, so here we have a very important rule in ionic compound. We must know that the amount of electron lost or the amount of positive charge must equal to the amount of negative charge, which means the number of electrons which are lost by the atom that gives the electron or the less electronegativity atom equal to the number of electrons which are gained by the high electronegativity atom. Okay, that means, for example, in sodium chloride, sodium loses one electron and chlorine receive one electron. So that's here. But for example, if we have magnesium atom, Mg loses two electrons during the chemical reaction and turn to be Mg positive 2 ion. Once it combined with chlorine just receive one ion, so just receive one electron only. So in that case, we have one more electron. Okay, so what should happen in that case? We need another chlorine atom to receive that electron. It means in that case, one magnesium will combine with two chlorine. So here, what like that. So to clarify the idea, just look at me carefully, guys. The part. For example, we said that sodium Na11. So Na11 it's 1s2, 2s2, 2b6, 3s1. So during chemical reaction, this electron will be lost. Chlorine Cl17, so 1s2, 2s2, 2b6, 3s2, 3b5. So we're gonna find this electron is easy to be gained here. So we're gonna find that sodium, after it loses this electron, it will follow the octet rule. That means the outermost energy level now is completely filled by 8 electrons. And here also, after it gained this electron, we're gonna find the chlorine will follow the octet rule too. So both are stable, and then that case it will be an ACl. That's a so the number of electrons which are lost is equal to the number of electron gained, or that electron which is lost from sodium is already gained by the chlorine. So in that case, okay, they are stay, or that's here the ionic bond. But let's find what would happen if we have magnesium Mg12. So magnesium have the electron configuration like sodium, except that the outermost energy level contains 2 electrons. So during chemical reaction, it will lose 2 electrons. These 2 electrons, if we combine with chlorine, so 1 electron could chlorine have this, okay, the same electric structure, so it could receive 1 electron. What about the other electron? So that means we should have another chlorine atom to receive this. So that will create a compound of MgCl2. So in that case, okay, there is a kind of ratio that one magnesium atom should combine with 2 chlorine. Why magnesium should combine with 2 chlorine, not 1? Because magnesium loses 2 electrons while chlorine receive 1. So that means each magnesium atom gives 2 and each chlorine just receive 1. So in that case, 1 magnesium must combine with 2 chlorine. And so on. I'm gonna give you another example. For example, here, if we say that aluminum Al13, so Al13, that means the last energy level, okay, 3s2, okay, and 3p, okay, equal 1. So we have 3 electrons in the outermost energy level. That means aluminum during chemical reaction, it will give 3 electrons. So if aluminum is gonna combine with fluorine, for example, F9, so fluorine is 1s2 to s2 to be 5. Okay, so in that case, fluorine just could receive one electron only. So in that case, aluminum cannot bond by one fluorine only, it must bond by three fluorines, each one receive electrons. So in that case, it will be AlF3. Okay, so here that the idea, guys. In ionic compound, okay, we are gonna find there is a ratio. This ratio must satisfy that the amount of the amount of electrons which are lost by the cation equal the amount of electrons which gained by the anion. So here, guys, let's back to our presentation. So we said that most ionic compounds exist in crystalline solids. So what are crystalline solids, or what are crystal? So that means a fixed pattern or a fixed arrangement of the ions. So a crystal is an ionic compound is a three-dimension of network between positive and negative ion. That means the arrangement of ions. How do you look like? So in case of molecular compounds, or in case of covalent compounds, okay, we can the smallest unit of molecular compounds is a molecule. We said that molecule, they are the smallest building unit of a compound, and we said that molecule just the word that describe atoms that connected together by covalent bonds, so we can't use molecule once we talk about the ionic bond. So what could be equal to a molecule in case of the ionic compound? In ionic compound, actually, like NaCl. Could I get just one NaCl? That means one sodium attached to one chlorine. I can't isolate one sodium ion combined with one chlorine ion in nature. At least I could get a crystal, okay, of sodium chloride. So that means we have the smallest unit, okay, of ionic compound, something we call it the formula unit. So the formula unit is the simplest collection of atoms from which an ionic compound formula can be established. What that mean? That mean here, guys, for example, in ionic bond, when atoms A is bonded with B ionically, so they are gonna be have a certain crystal, they have a certain arrangement as it's shown here in front of you. That means the cation A and B, they are gonna be arranged in certain manner to form this network, or that solid structure, which we call it crystal. So that is the smallest unit that I could pick. I never could get just one anion and one cation only. So here, like that, that's which we call that formula, or that we call that uh, molecular, sorry, that which we call the molecular unit or formula unit. While here, in case of covalent bond, okay, once we have two atoms, they are bonded by covalent bond. That means they share an electron. They will create a molecule. So in nature, I could pick up one molecule, or that means I could find a molecule separately or isolated from other. Yes, that means just one atom, like H2O, two hydrogen bonded with oxygen, that represent a molecule, that represent the all characteristics of the compound. So here, and they could be isolated from each other, yes, but in case of ionic, not. Okay, at least I must receive this crystal or this network structure. So here, like this, for example, that the sodium and chlorine, so sodium lose the electron, chlorine then get the electron that turn to positive ion, and chlorine turn to negative ion, and they will attach and form the sodium chloride. So here we see that we have something with the crystal lattice. Okay, what's crystal lattice? That's the crystal, the arrangement. So let's compare the crystal lattice here. We are gonna find that's, for example, the sodium chloride and that the cesium chloride. So here both are ionic, and both they share the same non-metal part, which is chlorine, but the difference is the sodium and cesium. So we're gonna find here the arrangement, or this crystal shape of chlorine represent that each sodium ion is surrounded by six atoms of chlorine. Okay, sorry, by four atoms of chlorine, while the chlorine is surrounded by four of sodium, and so on. While here in that case, we're gonna find each one of cesium is surrounded by about 1, 2, 3, 4, 5, 6, 7, 8 atoms. So here they are surrounded by 6, while here surrounded by 8. What make these two compounds have different crystals? Okay, although they both are ionic, both contain chlorine. So the difference back here to cesium and sodium. So what difference between cesium and sodium? They are different in the atomic number and the size. So like that, once the ionic bond forms, we have a kind of repulsion and attraction, and repulsion forces and attraction forces that gonna form, in which the positive nuclei of cesium and the positive nuclei of chlorine, they are gonna repel, and at the same time the positive nuclei of cesium and the electrons, okay, of the outermost energy levels are attracted. So they keep push and repel, okay, or repel and attract until they reach the certain distance or a certain arrangement that ensure the lowest potential energy, and in that case, the crystal is formed or give the final shape of the ionic bond. So here that the idea, okay, so we said that during formation of the crystal, there are forces, effective forces exist between positively or oppositely charged, okay, ions, and in the same time there is a passive forces that is already found between the similar charged parts like the nuclei and the electrons. They repel each other. So like this attraction and this repulsion force, we get the total. That means the total or the final energy between the attraction force and the repulsion force, which make ions are gonna sit distant from each other at certain distance based on the kind of atoms which are involved in the compound, and that which make each compound or each ionic compound have a certain crystalline structure called the crystalliths. So that's our session for today, guys. I hope that's very easy. If you have any question, please contact me. Study that part very well from your textbook. We're going to continue next time, inshallah.